Dear students, welcome back to the channel. Today we are continuing with the same topic of polynomials, finding the zeros and then verify the relationship between the zeros and coefficients. Okay. First question is this. This question has an issue. What is the issue? You all know. It is not in the standard form. The standard form is this: 6x squared. X square term should be the first term, and then x term. What is the x term? It is minus 7x. That sign also should come along with it, and then the constant term with the sign. This should be the standard. Once it is in standard form, then we can do as usual. You have to multiply 6 and 3. What is 6 into 3? It is 18. This 18 has different combination of products, like 1 into 18 is one combination, 2 into 9 is another combination, 3 into 6 is another combination. These are the three combinations. So let's try 6x square minus, put a bracket and then x, then minus 3. Look at the last sign. What is the last sign? It is negative. So you have to put negative sign within the bracket. And which is the right pair on subtracting getting 7? This is the right pair out of these three. Okay, first pair is 1 into 18. If you write 18 and 1 subtracting, you will get 17, but we need 7. So this is not the right pair. If you take 9 and 2, 9 you have to write in the beginning, a bigger number and then smaller. Then 6x square, open this bracket with minus into 9, minus 9 and multiply with x, 9x. Minus into minus 2 into x. Minus into minus is plus, and 2 into x, 2x minus 3. Then take the common factor from the first two. It is 3, because 6 and 9 both are coming in the table of 3, and x square and x is common factor. When 6 is from 6, when 3 is taken common factor, actually what we are doing, 6 divided by 3, it is 2 will come here. 6 is divided by 3, the quotient is 2 coming inside the bracket. And x square, from x square 1x is taken common, so 1x is left out. Minus, when 9 is divided by 3, the quotient is 3, only 1x, that x is taken out, so there is no x left out. And then after this, whatever sign, after two terms, whatever sign is here, that sign you have to put here. And I told you blindly you can write this bracket 2x minus 3 here. And when you compare this step with the previous step, here also 2x and the 3 only. So nothing different means what is common? 1 is the common. If there is no difference in this step and the previous step, common factor is 1. And now take this much as one term and this is the second term. Take the common. The bracket is the common factor for both of them. So take 2x minus 3 as common factor. And what is inside? Here 3x is remaining and here 1 is remaining. So 3x plus 1. After this, after getting two linear factors, we can find the zeros. To find the zeros, take the first linear factor 2x minus 3 is equal to 0 and second linear factor 3x plus 1 is equal to 0. Bring minus 3 to the right side, 2x is equal to 3 and x is equal to 3 by 2. And 3x is equal to plus 1 goes to the right side, it becomes minus 1 and x is equal to minus 1 and this 3 is multiplied, it goes to the other side and divided by 3. Therefore, which are the zeros? Zeros are alpha is 3 by 2 and beta is minus 1 by 3. These are the zeros. After this, you can verify Not in this form we have to get. Now we have to do verification. What is the verification we have to do? Two verifications you have to do. The first verification you have to do is alpha plus beta is equal to minus b by a. Sum of zeros is equal to minus coefficient of x by coefficient of x square. So take the LHS. LHS here is alpha plus beta. What is the value of alpha? It is 3 by 2 plus beta is minus 1 by 3. To add these two fractions, the easy way is multiply the denominator. 2 into 3, it is 6. And with this denominator, cross multiply the other numerator. 3 into 3, it is 9. Plus into minus, it becomes minus. 2 and 1 will be multiplied, you get 2. It is 7 by 6. Then take the RHS is minus b upon a. What is a in this? A not from the given form, we have to rewrite in the standard form. A is the coefficient of x square, it is 6. B is the coefficient of x, it is minus 7. C is the constant, it is minus 3. Now put the values. Minus, here this verification part has a minus. B has one more minus, so within bracket you write minus 7. By A is 6. This minus minus gets cancelled and you get 7 by 6. So both answers are equal, therefore we write LHS is equal to RHS. This is done. Now the second verification we have to do is alpha into beta is equal to C by A. Or we can say product of roots is equal to constant term by coefficient of x square. Take the LHS, alpha beta. What is alpha here? 3 by 2 multiplied by beta is minus 1 by 3. 3 gets cancelled and you get minus 1 by 2. And RHS, C by A. What is the value of C? C is the constant, it is minus 3. This is the constant, minus 3. And A is 6. You can cancel out by 3, the numerator and denominator, 1 by 2 minus 1 by 2. Therefore, LHS is equal to RHS. In this question, only one problem. The terms were jumbled. You have to rewrite in the standard form. The rest all are same. We will discuss about special cases. First special case is when constant is 0. When constant is 0, what we are doing or how do we do it? For example, ax plus ax square plus bx, but c is not there. Only this much is there. Then how do we do? Okay, ax square plus bx, only this much is there. How do we do it? Here it is, we cannot split, there is no need to split the middle term. The easiest method is this, when c is 0, that is the easiest form. We can take common from this. What is common to both? X is common, then you write ax plus b. Factorization is over. After this, equate each factor to 0 to find the zeros. To find the zeros, equate the first factor. First factor is only x equal to 0, and the second linear factor, it is ax plus b is equal to 0. This itself is a 0, x is equal to 0 is a 0, and plus b is taken to right side, ax is equal to minus b, and x is equal to minus b by a. Okay, these are the zeros. First 0 is 0 and second 0 is minus b by a. Okay, this way we have to do when c is 0. Suppose a question is given like this, here also no constant. Okay, let's discuss this. How do we solve this? Take x common. When x is taken common, we get 3x plus 5 factorization is over. Then to find the zeros, equate each linear factor equal to 0. X is equal to 0 and the second one 3x plus 5 is equal to 0. This itself is a 0 and shift this plus 5 to right side and 3x is equal to minus 5 and x is equal to minus 5 by 3. This is the second 0 and this is the first 0. Therefore zeros are alpha is equal to 0 and beta is equal to minus 5 by 3. So you get both the zeros. Now we can start the verification part. Two verifications you have to do. First verification, alpha plus beta is equal to minus b by a. Take the LHS. Alpha plus beta. What is alpha's value? It is 0 plus beta is minus 5 by 3. On adding we get minus 5 by 3. This is the LHS. Yes, we have done. Yes, LHS we have calculated. Now we are going for RHS. RHS is minus b by a. Okay. What are a, b and c? A is with what is with x square? It is a. What is with b? It is x. What is with x? It is b. B is 5. C is missing here. C is constant. Is 0. Missing means it is 0. Minus b. What is the value of b? B is 5 and a is 3. So we get both answers same. Therefore we write LHS is equal to RHS. Now we have to do the second verification. Alpha into beta is equal to c by a. Take the LHS. Alpha into beta. What is the value of alpha here? Alpha is 0. We have calculated already. Alpha is 0 and beta is minus 5 by 3. When we multiply this, we get 0. Take the RHS. RHS is c by a. C is constant. Constant is 0. By a is 3. It is also 0. Therefore, LHS is equal to RHS. Okay, this way we have to do when C is 0. The next case is when B is 0, that middle term is missing. That means only ax square and c is there. There is no b. Okay, how do we do this type of questions? Okay. When we do this type of questions, be careful. The sign of C is always negative. It is never positive. It should be negative in all the cases where b is 0. Otherwise, we won't get real values for x. Okay, you will get complex roots. So, we can take some example like this. X square minus 15. Okay. One question we can take it like this, x square minus 15. How do we do? There are two ways we can do it. The first method is, we have to equate it directly equal to 0. and shift this plus 15 to the right side, and we get x square is equal to plus 15, and then cut the square and put here root with two roots, plus or minus. That means x has two values, one is plus root 15 or x is minus root 15. So these are the two zeros we get. What we have done, I will explain again. This we are equating equal to 0, shift the constant to right side and then cut the square, put the root. Two roots, one is a positive root, other is a negative root. These are the zeros. One of them we can write it as alpha, other one we can write it as beta. Hope you understood. This is one method. Another method, second method is x square minus 15. As per this chapter, we have to make two linear factors. Okay, we have done when all three terms were there, when constant was not there, then also we took x common and another bracket we got, that bracket is also a linear factor, x is a linear factor. Okay, here also we are trying to make two linear factors like this, and we follow the same pattern, x square minus, instead of 15 we write root 15 the whole square. If it is a 36 or like perfect squares, for example 36 is there, then we can write 6 square. Okay, if it is 1 we can write 1 square. If it is 4 we can write 2 square. If it is 9 we can write 3 square. But 15 is not at all a perfect square, but still we have to write it in the form of a whole square. Then you put a root and then whole square. So it follows which identity? A square minus b square identity is followed, and then we can write a plus b into a minus b. When it is written like this, the squares are removed and we add one time x plus root 15 and x minus root 15. After removing the squares, we have to add one time and other time we have to subtract. That is the meaning of a plus b into a minus b. Now both are linear factors. To find the zeros, what we have to do? Equate each factor to 0. X plus root 15 is 0 and x minus root 15 is 0. Then shift plus root 15 to the other side, x is minus root 15 and x is minus root 15 goes to the other side, it will become plus root 15. Okay, both answers will be same. Method is little bit different. This is the method the textbook prefers because they are telling every polynomial, quadratic polynomial, you have to factorize into two linear factors, and each linear factor you have to equate to 0 and then find the zeros and then verify the relationship. We can do verification here also. Verifications, not only one, two verifications you have to do. First verification is alpha plus beta is equal to minus b by a. Take the LHS, alpha plus beta. Alpha is root 15 plus root 15 or simply root 15 plus the second is minus root 15. When two additive inverse are added, two numbers but with opposite signs are added, the result is 0. 2 plus minus 2 is 0. 5 plus minus 5 is 0. Okay, two additive inverses are added, the result is 0. RHS minus b by a. Okay, let's take what is a here, what is with x square is 1. X term is missing, so if you want you can write this is 0x. So b is 0 and the constant is minus 15. So we can write minus b is 0, 0 has no sign actually, a is 1, so the result is 0, both results are same, therefore we write LHS is equal to RHS. The first verification is done, and now we have to go to the second verification. Alpha into beta is equal to C by A. Take the LHS. Alpha into beta. Alpha is root 15 and beta is minus root 15. Root 15 multiplied by minus root 15. When two roots are multiplied, like roots are multiplied, the root will disappear and only 15 and minus. Understood? Root 15 to root 15 is 15 and minus sign is there. And RHS, C by A. C is minus 15 and A is 1. This is minus 15. So both results are same. Therefore, LHS is equal to RHS. Okay, this is the finding zeros. This is the finding zeros and verification part is over. Now, next class we will study how to frame a quadratic polynomial when zeros are given, or sum of zeros, product of zeros are given, or one polynomial is given, using its zeros develop another polynomial. Such type of questions we will discuss in the next class. Okay, hope you understood today's topic. Thank you.